Hi YouTube, you are watching Simple Coding. This video is part of a tutorial series about how to build a microservice using Spring Boot. In today's video, let's talk about the different types of request methods in a Spring Boot based RESTful APIs for building a microservice. Throughout this series, I'm going to use a RESTful API and a microservice interchangeably. This tutorial series is for Java developers who have never done any web application development or are not familiar with the Spring framework. In today's video, I'm going to cover these topics. What is a resource for RESTful API and microservice? What are the most commonly used request methods and what each method will do to a resource? What are the most commonly used HTTP status codes and which code could be used by which request method? How to implement these request methods using Spring Boot, including how to return a response entity object with proper status codes. A few tips about RESTful API functional design. So let's get started. In order to explain different RESTful API request methods, we have to understand what is a resource. In a nutshell, in the context of a RESTful API and microservices, a resource is an abstract definition or a concept and refers to an entity of a specific type. It can have associated data. It might have some relationships with other resources. And we can also perform a set of actions on it. As long as these criteria are met, a resource can be anything. So a resource can be mapped directly to a real-life entity, such as a bank account, or an online order at Amazon, or employee's profile in a company's HR system. A resource can also be mapped to a more abstract entity. For example, it could be a financial transaction happened to a bank account, or a row of data stored in a relational database, or even a batch job that processes large amount of data. In the context of RESTful API, a resource is often called web resource. A resource can be represented through a URI, Unified Resource Identifier, which is a part of a web URL. In fact, for most of the times, the name of a resource or a collection of resources of the same type will appear in a RESTful API's request path, such as this one. Next, let's talk about a set of actions you can perform on a resource. You probably already heard of this acronym, CRUD. CRUD stands for Create, Read, Update, and Delete. Although this acronym represents the 4 basic operations on a piece of data stored in a database, the software industry found that they could also represent the basic request methods on a resource for RESTful API. In fact, if I scroll down this Wikipedia page about CRUD, you will see the exact mapping between these 4 operations with another 4 request methods under the header RESTful Web Service, which is synonymous with RESTful APIs. Here is a list of all commonly used request methods. GET, which is used to retrieve the information of a resource or a collection of resources. POST, which is used to create a resource. PUT, which is used to update a resource. Here, I must point out that another request method called patch is also commonly used to update the resource. There are subtle differences between put and patch, but within this video, I'm not going to go to the detail. Delete, which is of course used to delete a resource. Each RESTful API must be implemented based on the predefined intention of these 4 methods. For example, if a RESTful API is marked to take POST method, its implementation shouldn't delete the resource. because such implementation is against the intention of the request method for this API and would confuse the service clients. Therefore, the request method for a RESTful API is like a contract between a microservice and a service client in terms of which resource operation the service client should expect. Enforcing such a contract during the API design and implementation will improve the quality of your microservice. Next, let's talk about the HTTP status codes. Each RESTful API must return a status code to the service client after API execution. These status codes are very similar to the return codes of a program function call. In some coding practice in some companies, a function returned in a particular language could return status code indicating the resultant condition of the function execution. The purpose of HTTP status codes is very similar. They are the codes that a RESTful API will return to the service client after the request of this RESTful API has been fulfilled, regardless whether the execution fails or succeeded. Each status code contains 3 digits and can be grouped together into different categories based on the first digit. The most common categories are 200 category and 400 category. Another common status code is 500, which indicate internal error. To make it easier to understand, let's walk through all 4 request methods to see what status codes each request method could return. First, let's look at the workflow of a GET API. Here is a RESTful API that will return the detailed information of an account based on the API's request parameter account ID. After the API starts to execute, it will first verify if the account 123 does exist in the system. If it does not exist, the API will return status code 404, which means not found, or 204, which means no content. Which code will be returned really depends on your design choice. If the account does exist, the API will try to retrieve its information and put it into the API response, along with the status code 200, which means OK. Let's look at a more complex GET API. This time there are 2 types of resources. The first one is account ID, which is embedded in the middle of the API's URL. Such an API parameter is also called path variable. The second type of the resource is transaction. Actually, this API will return the information of all the transactions happened to this account 123. Although you probably don't want to do that, as the data returned by this API could be a lot. So you might want to cut the data into pages and return 1 page per API call. This is a more complicated API because the status code returned will depend on 2 types of resource, not just 1 resource. Let's walk through its workflow. After API receives a call, it will check to see if the account 123 does exist. If not, it will return 404, not found. Here you may not want to return 204, which means no content, because you want to inform the service client the system cannot even find the account 123, so that it cannot even try to retrieve the transactions, which are the real content of this API. If the account 123 does exist, the API will determine if any transaction for the account does exist. If it does not find any transaction, the API will return 204 to indicate no content. If at least 1 transaction is found, the API will retrieve it and return 200, which means OK. Next, we will look at a post. Since a post will create a resource, usually it requires a special piece of data called the request body. To Spring Boot, a request body is usually mapped into a POJO. but the value of each property in the request body is not guaranteed to be correct and it needs to be validated. If no data validation is performed, there is a much higher chance the API will return 500 internal error, which could frustrate the service client. So after API is called, the first task is to validate the request body. If the validation fails, API will return 400, which means bad request. If the request body is good, the API will try to create a resource, in this case, a new checking account. If the creation is successful, the API will return 201, which means the resource has been created. Otherwise, the API will return 500 internal error. Because this is unexpected, as the API already performed validation on request body to ensure the resource could be created. Similar to a post, a put or patch usually also expect a request body that contains information for how the resource will be updated. Similar to a get, the first step is to check if the account 123 can be found. If not, return 404 not found. If yes, validate the request body. If validation fails, return 400 bad request. If yes, go ahead to update the resource. If it's successful, return 200, otherwise 500 internal error. Similar to a get API, a delete API will return 404 if it cannot find the account 123. If the account is found, the API will try to delete the account. If successful, return 200, otherwise 500 internal error. The 500 code here does make sense because the API should be able to delete the resource if the execution can reach to this point. Next, let's demonstrate how to create these four types of RESTful APIs using Spring Boot. At the end of the first video, a simple GET API was created, which is what we are looking at right now. It is a simple API that only returns a string. Although implementation will return status code 200 due to the default behavior of Spring Boot, it will require some extensive coding to return other status codes if we do not use some out-of-box features from a Spring framework. In this case, we will use a Spring generic class called ResponseEntity as the output of this GET API, like so. We will also wrap the original string into an object of this class within this method, like so. We may also return 204, which means no content, via such a ResponseEntity class. To demonstrate this, let's extend this method with an if-else structure, like so. Now you see this API will return 204 if an account is not found, which we figured by looking at the account ID's value. Earlier in this video, I mentioned a special API parameter called path variable. Let's try to use it in a new GET API called GET transactions. To use it, we have to specify this path variable inside of the request mapping annotation. Notice there is a curly bracket parameter between the checking accounts and the transactions in the path property. This is the indication this is a path variable. To match it with the function input account ID, we have to add the path variable annotation. This is how you use a path variable in a API function. Next, let's create a post API that takes a request body object. For the demonstration purpose, I already created such an object called checking. It has two properties. One is account ID as a string. The second is account name. We must also add a getter and setter for each property. Now, let's use this class in a new API method called createAccount. Which takes one function method as checking as an object of the newly created checking class. Remember, we can return 201 created as a return status if the resource has been created successfully. Let's just use a ResponseEntity to do that. We will add the request mapping with methods post and the path as. To specify the checking parameter for this function is a request body. We also needed to add a request body annotation. That's it. We create a post API. To create a put or patch, we need at least two parameters. One is a request parameter called the account ID to indicate which checking account needs to be updated. And the second is a request body called checking that contains new values for some of the account properties, such as account name. Let's do that. We will return from this API as OK. Let's add a request mapping annotation with the method as put and the path That's it. We created the or put API. Now let's create a delete API called delete account. It takes one function parameter called account ID. We will indicate that this is a request parameter, so let's use that annotation. This function will only return OK. Let's add a request mapping annotation with method as delete. And the path is still the same. Now this API is completed. By now, you might have noticed that each API, the path, started with the same phrase /checking accounts. We can put a global path on top of the class declaration like this. If we specify like this, any API within this class will start with /checking accounts. So we can remove the setting for each API. Like so. Notice that for the get transactions API, we still need to use a path. This is a path that will be concatenated behind this global path. So the end result will be slash checking account slash account ID slash transactions. Before we conclude this video, let me share a few tips on how to design RESTful APIs based on my experience. Use common sense. Sometimes it could be difficult to decide which status code should an API return for a particular case, and you might have multiple codes to choose from. Use common sense and think from service client perspective to see if your choice of status code makes sense. Keep consistent and avoid such case of using different request methods on different resources for the same action. Keep simple and avoid using one single API to act on multi-level resources at the same time. Learn from other public RESTful APIs and their published specification documents, as most of them have been thought through quite extensively over several versions. So that's it, folks. This concludes this video. If you would like to provide feedback, please leave comments below. If you like this channel, please subscribe. If you like this channel to provide tutorials on other languages, frameworks, and technologies, please let us know. Until next time, happy coding!